from Sensefly company, Switzerland.
All right, hello everyone. So first to introduce myself, I'm Alexis Rose. I'm actually working in Switzerland. I'm originally French. And so I've been working for Sensefly. It's been 3.5 years now that I've been working for Sensefly. And well, we mainly dedicated to drones. So just civil drones, mainly for mapping, but we also work for agriculture, inspection, and I'm going to tell you more about this in the presentation. Before starting, I would like to know who have ever heard about drone mapping, who have ever seen a drone flying. Just a quick survey just to see how much people know about drones.
چند نفر از دوستان در این جمع آشنا هستن به مسائل پهپاد و نقشه‌برداری بوم دستشون بلند کنید.
All right, nice. Nice. So it's half I would say, like 50-50 of the room. So I hope that the people that never heard about it, they will know more. Today that's the objective of the presentation. So first of all, I'm going to introduce the company I'm working for. The company is called Sensefly. It's a Swiss company founded in 2009. And to give you a rough idea about how fast we grew up, we're now more than 130 employees. We're mainly based in Lausanne, Switzerland, but half of our, 10 of our colleagues are working from the US in Washington, D.C. We had, as you saw, we grew up pretty quick, and we had a few awards lately. Especially, we have been elected in the top 5 Swiss startups. And everything is in Switzerland, from development to sales and R&D. Everything is based in Switzerland. And well, last but not least, we got acquired by a French group which is called Pardaz, which is well known for toy drones. So we kind of the professional department of the Pardaz group. So Pardaz is a public group, a French public group. So today I'm going to basically introduce all our different products. We have 3 different products, and to start, I'm going to just quickly show you what makes the drone surveyor tool. So the first thing is that we have to make sure that it's easy to use, because people are already used to GNSS, they're already used to total station, but the drone is a new thing, and we just make sure that people would use it with ease. Obviously, it has to be safe. That's something that is flying in the air, so we have to make sure that it's not crashing one flight out of 2, obviously. Portability, we can travel, it's pretty easy, you can see the box is pretty small. Reliability means that you can do as many flights as you want. We have to make sure that the user has all the software that goes with the drone. It's not about just flying, but it's also about taking pictures, georeference pictures for the mapping, and then obviously the price. Just to give you a quick idea about what's the workflow here. So it's pretty simple. I'm sorry for the bad quality actually. It's pretty simple. It's the drone you see here, it's called EB. You take it out of the box, you have 2 wings that you assemble. Then you have a flight planning software. So on your laptop, you basically plan your flight. It's pretty easy. You set the area, you shake it 3 times, the drone, it turns the engine on, and you launch it. While in the air, it takes pictures, so georeference pictures based on the GPS. And after the flight, it lands by itself. And it has a 5-meter accuracy at landing. So everything is done by the autopilot, means that there is no need of piloting skills. So you don't need to pilot it manually. The product you just see now is the EB, so that's a standard EB with a standard GPS. It's a fixed wing, what we call a fixed wing drone, so it means that there are fixed wings. These are the three products that we have in our portfolio. We have the EB with standard GPS, we have the EB RTK, so it means that instead of having standard GPS, we have a double frequency GNSS on board that allows the EB to take georeference pictures with a high accuracy. So what's the EB like? The EB is like 700 grams, so it's really light, but still the autopilot allows to fly with a wind speed of 12 meters per second. So just to give you a rough idea with the presentation right before, an aircraft would fly at 300 kilometers per hour. This drone flies at 10 meters per second, so it's approximately 45 kilometers per hour, so 6 times slower. So obviously we have no problems of blurry images on this kind of thing because we have much more time to take the picture, just to sum up. It can fly for 50 minutes with the best wind condition, and you can have an accuracy, so it can take picture with a resolution of 1.5 centimeters, and the best accuracy we can have is down to 3 centimeters. It is based on the ground control points you put on the ground. We have multiple sensors that you can put on board. Obviously, they are not ultra-cam camera because we need to be light, so the heaviest sensor that we could put on board is 550 grams. We have standard RGB cameras, we have high-end RGB cameras, but we also have a multispectral sensor and thermal sensor. So it's really like we try to develop new sensors just to make sure that we fit all the different applications. The second product that we have is EBRTK, so that's the same way to fly, so it's fully autopiloted, but the difference is that we have a high-end GPS and GLONASS board in the drone. It still has the same, I would say, like the same weight, the same capacity, obviously it's a bit heavier, so it flies a bit less long time. But the idea here with the EBRTK is that you can create orthomosaic DSM point clouds, as we just saw before, but with no ground control points, you can still achieve a really high accuracy. This is the main difference between EBRTK and standard EB, is that if you want great absolute accuracy, you need ground control points with standard EB. You don't need with EBRTK. How does the EBRTK works? So I guess that you're all familiar with the RTK technology. You have a base station, you have a rover, and the base station is on a known point, and it sends correction to the rover. In the case of the drone, we have a base station, so people can use the base station that they have already in the office. It can be either Leica, Topcon, Trimble, CHT, whatever the brand, as long as it streams RTCM free. Then the base station streams the correction to the ground station, which is the software Emotion. That's the software on the laptop, and the laptop streams the correction to the drone. So the drone is the rover, and when it takes pictures, it takes pictures with the GPS board as a high frequency, and then it interpolates to get the exact correct position, I mean with a centimeter accuracy on the picture. When we brought RTK to the drones, the answer is pretty simple. As I said, it's a gain of time because it's faster. You don't spend your time on the ground surveying your ground control points. It can be safer as well if you're working in mining site, quarries. You don't have to go down if there is big trucks. You don't have, once again, you don't have. It's safer to not cross the path of big machines, and it is as accurate. Obviously, we don't just produce the drone. We have a photogrammetry software which is called Pix4D Mapper. They are our partner from Switzerland, and they develop all the mapping part, which means, as we just saw before, actually, the creation of a point cloud, of a colorized point cloud, so there is no LiDAR, it's only based on the picture, colorized point cloud, then DSM, then orthomosaic, and obviously we have a few cool features like volume calculations on the fly, digitization of the models. The software that we use for the flight planning is called Emotion 2. And it is used for both EB and EBRTK, and I'm going to, actually I have a video, but I'm going to show you live this. So basically that's what we have when you connect the drone on the software. You have the position of the drone thanks to its GPS. We have a radio link at all time between the drone and the base station. You can see here there is few points, few interesting points. You have what we call the start waypoint here, which is the first waypoint of the flight, and you have the home waypoint with the landing strip, which is the last waypoint of the flight. In between, you want to map an area. So to map an area, you just draw the area of interest, you resize the area, you can easily convert to polygons. You define the resolution, so the size of one pixel on the ground, for example 3 centimeters, and the lateral overlap and longitudinal overlap between the lines. After defining these 3 steps, so I click upload, and the mission plan is sent to the drone, into the autopilot. Then, as you saw in the video, you just shake it 3 times and you launch the drone. This is what you see while the drone is flying. So you don't have to care about piloting the drone. The drone flies by itself and takes the pictures by itself. At the end of the mapping, it comes back and lands automatically. So the surveyors, the professionals, just have to focus on the results and not on the flying part. That's the idea of the product. You don't have to be specialist in the flying part, but just focus on the results. If we lose the communication, that's a good question. If we lose the communication, remember that the flight plan is in the autopilot. Means that the drone will still fly on its path, on its predefined path, and there is also a lot of safety procedures, and if it loses communication, for example, for more than 30 seconds, it would come back home and land. Alright, so it takes a bit of time, so you can see the whole flight. Now it takes pictures. And so I'm not going to show you the whole flight, but basically you can see it when you take pictures. So back to the presentation. So now you've seen everything about our fixed-wing drones. And I would like to show you this table about what's the difference between rotor systems and fixed-wing drones. It's pretty easy to understand, I guess, that with fixed-wing drones you have to fly a bit higher, because you have to fly like a plane, so that you don't want to crash into buildings and trees. So the resolution obviously is lower. You need more space to land as well, because it's like an aircraft landing. But on the other side you can cover more areas. The battery time, you have just 1 engine to power instead of 4, so you have much more flight time. Some examples of what people are able to do with our drones. This one is a special project in Australia, and you can see that people flew 250 kilometers with a resolution, if I'm not mistaken, of 5 centimeters, and with EBRTK. And over the whole project, the accuracy was less than 10 centimeters. Most of the case, it's way better. But he has, on all his checkpoints, so I think it's like 125 checkpoints, the vertical accuracy was less than 10 centimeters, without using point on the ground. So the point on the ground are just used as checkpoint, verification point of the accuracy of the EBRTK. So that's a screenshot from the ortho mosaic. So this is a long corridor. We have the contour lines here, so imagine that it's a map of 250 kilometers of contour lines. And we have a short video of a section. So this is a 3D point cloud. This is a dense 3D point cloud, so you cannot even see that it's a point cloud because it's so dense. And this is basically a short video of what the EBRTK and EB are capable of doing. Thank you very much for your attention.
سوالی هست دوستان؟ بفرمایید. میشه میکروفون هست؟ مدل این دستگاهی اینجا هست. این asking about the model of this existing model. The model? which model? EB, normal
Yeah.
EB?
This one is EB. So the difference between EB and EB RTK is just that there is a different GPS board and different antenna. The antenna is a bit bigger, but this one is EB. This one is the most fixed wing drone sold in the world. We produce around 100 units a month. And in our database, we have more than 250,000 flights from our users all around the world.
What is your advantage comparing with the UX5?
The main advantage of UX5, that's funny because we were talking about that in the car yesterday, and the main advantage of UX5 is the ease of use. The UX5 is 2.5 kilos, or 2.5 kilos, and you need a catapult to launch it, and everything is bigger. So I'm not saying the UX5 is a bad product. Definitely they have a good product, Trimble has a good product, but the thing here is that we realize that people need more portability and ease of use, especially with the flight planning software. And if for support reason as well, that the material you can definitely come and hold it. The material is flexible, so the material is EPP. And it's flexible, so if it lands, for example, it can land on stone, on grass, whatever, it doesn't break. That's the main thing as well. With bigger aircraft, bigger drones, they usually have to replace the old parts when they break, because if there is hard landing. At landing, we're also much more accurate at landing. This one is 5 meters accurate at landing, because we have an extra sensor, not only based on GPS, but you have an extra sensor here, which allows the drone to land smoothly and brake at the right time. That's the other thing that other drones doesn't have as well.
در پاسخ به هر حال UX5 هم دستگاه خوبیه، هیچ ایرادی فنی بهش نیست. نکات اختلافاتی داره که اون 2.5 کیلو وزنشه، این خیلی سبکه. دومی که متریالی که این دستگاه باش ساخته شده بسیار نرم و منعطف هست. در اینجا با هواپیما بزرگتری روبرو هستیم. اون نیاز به پرتاب کننده یا لانچر داره یا کاتاپالت میگن اصطلاحاً. از یه دوستی که در کانادا کارش UAV هست من سوال کردم وضعیت توی کانادا و آمریکای شمالی چگونه است. به من گفتن که از هر 10 تا UAV 2 تاش UX5 8 تاش Sensefly هست. علتش رو جویا شدم. گفتن بیشتر مردم از لحاظ روانی پرتاب کننده رو دوست ندارن. این مدل چون با دست پرتاب میشه و خیلی سبکه و نکته دیگری که اضافه کردن سنسور اولتراسونیکی زیر هواپیما هست. هنگام فرود مرتب از برخورد سنگین جلوگیری میکنه و با دقت 5 متر در موقعیتش فرود میاد.
موقع فرود تو فیلم میده اینا روی زمین همینطور فرود اگه زمین سخت باشه یا آسفالت باشه سنگ جلوش باشه آسیب نمیبینه.
What if the landing ground is rough, is very hard, for example, asphalt and the road?
There's definitely no problem. There's no problem landing on a hard land. Obviously, you're going to maybe affect the landing belly a bit, like I would say, like faster. But after 100 or 200 flights, you can definitely change as well the wings. Everything is replaceable. So probably that you're going to affect the belly faster.
So the cost of support is much.
Yeah, probably exactly. That would be the.
نکته‌ای که در قسمت قبلی من فراموش اضافه کنم هزینه نگهداری هواپیماست که قطعات خیلی سبک‌تر و ارزان‌تره در مقایسه با اگر بعداً از نزدیک ببینید در شکم این هواپیما جنس خیلی سخت‌تر هست که برای فرود کار آسان‌تر می‌کنه. برای با همه تمهیداتی که اندیشیده شده و با قطع یدکی که فراوانی که قرار تامین باشه محلی هزینه شما در مجموع بسیار قابل تحمل و قابل قبول خواهد بود. بفرمایید.
گفتن که طراحی پرواز به صورت اتوماتیکه. سوالم اینه که در طول عملیات میشه پارامترها رو رد کنید یا اینکه هیچ شانسی برای
Can we change the parameters on the fly if we want to correct something?
Yes, everything. You can change everything. You can even if you got mistaken in the area of mapping, you can change the area of mapping. As long as you have a connection, you can upload on the fly the mission.
Maximum range?
Up to 3 kilometers.
So the question is, what if we have vibration or if it was side wind?
Yeah, so
because we do not have a gyro stabilizer.
Yeah, exactly. So basically, we used first of all when there is side wind. So the plane, the autopilot will compensate by itself while flying. Will compensate by itself. For example, if you have side wind, the plane will fly like this, just to make sure that we take. I mean, we have the good flight path. After for the photogrammetry, we have, for example, we shut down the motor 1 second before for a really short time, just to make sure that the plane stabilized while taking pictures. That's definitely a good point. So that's what I was saying just before, is that even when stabilizing, I'm not saying that the aircraft is always like straight. So definitely some picture can be like this with a bit of pitch as well, but you compensate that with the overlap. So it means that we have a much higher overlap than a standard photogrammetry survey. We go with 80, and also keep in mind that the software we're using after, PixPolymapper, is computer vision based software, so it's only based on the picture and not much on the orientation of the drone. To give you an idea, but the software doesn't use, the reconstruction software doesn't use the orientation. It just uses the GPS accuracy, or GPS position and GPS accuracy, and the key points, what is in the picture. So the most important thing for the convex construction is the key points, the points we have in the scene on the pictures, and that you have like multiple pictures covering the same point. For example, you can have 20 pictures, standard flight, you can have 20 pictures covering the same scene.
I'm down here with Pardaz.
حالا دیگه وقت پروازه، روزای خوب تو راهه، اینقدر انگیزه داری واسد، سقف آسمونم کوتاهه، مگه میتونم تو اوج قله کسی رو غیر خودت تصور کنم، بازم دوباره ستاره میشی که آسمونو با اسم تو پر کنم.